So perhaps I should get moving with just some of the housekeeping here, and afterwards I can type in the chat just so that everybody knows. So welcome to the session first of all, and it's so great to see so many people here. We're going to have two sessions for climate because this was really the subject that so many people were interested in. So housekeeping, please keep your microphone muted when the speakers are talking. I think most people already have, which is fantastic. And also please don't feel that you need to have your camera on through the whole chat. If you're having internet problems, feel free to switch that off. And also we thought we would just have all the questions at the end rather than breaking in between the talks. So while it's fresh in your memory, please just type into the chat box, and provided we have enough time, we'll read those out at the end. Okay.
So the time is flexible, not only 15 minutes for each talk.
Yeah, that's it. I mean, we don't have a full session today, so if we're not going to be sort of telling you to be quiet at you know, at 15 minutes. It's not going to be quite as strict today.
Okay, that's good.
I'm just having some problem with my computer. Sorry. I just stopped the video for a second. Okay, here we are. So I thought we would just introduce ourselves. I don't know if Jen, you'd like to go first and just introduce yourself to everybody.
Sure. Hi, everyone. I'm Jen O'Keefe. I'm over here in Kentucky, USA. I'm a palynologist and organic petrographer at a very small school here. I mostly work in fungi these days. NPPs and fungi make me most happy. And welcome to our session today.
Yes, thank you, Jen. Yoshi, would you like to say hi?
Yes, great. How's my mic volume?
Great.
Excellent.
Okay, super. Sorry. Good morning, everyone. My name is Yoshi Mayazumi. I am currently based at the University of Amsterdam, though since COVID I have been adrift, and I'm currently in California en route back to Amsterdam since the lockdown started. I am a paleoecologist, primarily working in the Amazon and Caribbean region, and I'm very delighted that you all are here today, so thanks for joining us.
Thank you. Limi, would you like to say hi to everybody?
Yes. Hi, everybody. Very nice to meet you online. Thanks to modern technology, we have this chance to enjoy together. So my name is Limi Mao from Nanjing Institute of Geology and Paleontology. Actually, I'm doing quaternary pollen analysis as well as modern pollen morphology and fossils. So my study interests also include mangrove palynology and paleoecology of mangrove, and also pollen indicators of human activities. So nice to meet you. So enjoying our palynology short talks. That's all.
Thank you. And I can just introduce myself. I'm a PhD student at the University of Southampton, and I'm interested in past ecological change on South Pacific Islands and the effect of disturbances on vegetation, such as the arrival of humans and things like volcanic eruptions. So yeah, and I think the feeling for me was that it was so sad that because of coronavirus, we were all sort of apart and not attending conferences. So it's just nice to be able to share this and to meet everyone still. And I'll just show you that we have some future sessions. So the next session is going to be about the human interaction with vegetation, and then we also have a student research showcase, which is already full. So I think we're going to see if we can possibly make more spaces for that, and we'll get back to you on it. Then we've got a session on deep time palynology, environmental change, landscape reconstruction, and ecological management. An infographic session, so that will be a graphic that will be showcased on the website, which will be accompanied by a 2-minute talk. And Palynology and Climate Part 2, biodiversity, ecological interactions, range shifts and database science, palynomorphs and associated environmental indicators, vegetation disturbances and fire, and finally, pollen production, dispersal and taphonomy. So if your subject isn't covered by one of these, just let us know and we'll see if we can sort of accommodate you somehow. And just some statistics now from the talks that people from all around the world have responded, which is just fantastic. And we have in the red colour there the uptake for the talks, and typically the 6 free spots for each talk ready. So I'm going to stop sharing my screen now, and I think Limi is going to introduce, oh no, sorry, I've skipped over. I don't know if Jen or Yoshi want to say anything else before we start.
Yeah, the first speaker, Dr. Wu Jing. She's from Institute of Geology and Geophysics, Chinese Academy of Sciences. Now, her position is assistant researcher there, and her study interests including climate change on the centennial to millennial timescales. And her ongoing project is about vegetation response to climate change during the last deglaciation in the Great Hingang Range area from northeast China. And also she's doing pollen and stomata records of later glacier vegetation in the Great Hingang Range area. So this is Dr. Wu Jing. And the third speaker is Dr. Yu Xiaohua. Now she's working in Guangzhou Marine Geological Survey, and she's a researcher there. And her study interests including marine palynology and coastal environmental change. And her ongoing project is international grant. It's about evolution of Hainan data as response to the paleo environment science in the later Pleistocene at the South China Sea's northwest shelf. So let's wait, look forward their talks soon. Yeah, Ichira. So let's begin with the first speaker. Or okay. Yoshi, you want to introduce Vita?
Limi, I think I will at the after the first talk, and then when we transition into the next one, I'll go ahead and introduce him for anybody who comes in a little late.
Perfect. So Wu Jing, please.
Okay, that works. Okay. Hello, everyone. Thank you for the organizer giving me the chance to let me present that how to use pollen records to reconstruct the evolution of the East Asian winter monsoon. East Asian winter monsoon. East Asian winter monsoon is a part of the East Asian monsoon system, which will bring the severe cold surges and heavy snowfall to East Asia in winter. Previous studies have indicated that the East Asian winter monsoon and the monsoon are tightly coupled. The strong Walker circulation will cause the La Nina event and the strong East Asian winter monsoon. The Northeast China will have an extremely cold winter. In reverse, the weak water circulation will cause El Nino event, weaken the East Asian winter monsoon, and the Northeast China will have a warm winter. This linkage is verified by the modern observation on the indicadal to decadal timescales. However, it is unclear on the centennial to millennial timescales, like whether the linkage between the ENSO and the East Asian winter monsoon exists in Northeast China throughout the Holocene, and how do they link? To answer these questions, we need to find the prospect of the East Asian winter monsoon in Northeast China. It is not an easy work, as the existing records are located near the limit of the East Asian winter monsoon, where the winter is relatively warm, but in Northeast China, the winter is extremely cold. Sometimes it's too cold for people to feel the temperature change, because the only thing we can do is staying at home, drink Chinese baijiu, and get drunk every day. But vegetation can tell us. We find out that the boundary line between the boreal forest and the temperate forest is determined by the winter temperature. Therefore, the immigration of piners and cocos into the boreal forest represents an increasing of the winter temperature, and it's linked to the shrinkage of the East Asian winter monsoon. So we decided to find lakes located near this boundary line and use the pollen analysis to reconstruct the vegetation history and the evolution of the East Asian winter monsoon. Fortunately, the Arshan Chaihe volcanic field is located on this boundary, and there are many coves, cathedrals, lava dam lakes, and crater lakes in this volcanic field. The potential Mar Lake, Woniupao, and the crater lake Moon were chosen for drilling. Lake Woniupao is a heart-shaped lake located in a category. The maximum depth of the lake is 1,450 meters. The minimum rise is 900 meters, and the maximum water depth is 2.3 meters. The regional weather is controlled by East Asian monsoon system. And 364 centimeter sedimentary sequence was obeyed, spanning over 5,000 years BP based on the radiocarbon-14 ages. 164 pollen samples was analysis spanning the last 10,700 years BP from lake sediment. The results of pollen analysis shows that the vegetation in study area throughout the Holocene is forest steppe, composed by boreal forest, temperate forest, shrubs, and herbs. Before 9,200 years BP, the forest coverage is relatively low. The steppe component is dominated by Poaceae, Artemisia, and Aberranthus, while the forest component dominated by Betula. From 9,200 to 5,700 years BP, with the decretion of the Poaceae, Cypaceae, and Silicotrium, the steppe component becomes dominated by xerophytic herbs like Artemisia and Amaranthus. After 5,700 years BP, the forest is densest and most diversified, mainly composed by Bachelor, Cocos, and Pinus. The other lake, Noon, is a small circular lake with a diameter of 220 meters and the maximum water depth is 6.5 meters. The elevation of this lake is about 500 meters higher than that of Lake Woniupao, which means the local climate is colder and drier. An 886 centimeter sedimentary sequence was obeyed spying over 20,000 years BP based on radiocarbon 14 ages. 272 pollen samples were analyzed spying the last 10,800 years BP. The results of pollen analysis are similar to those of Lake Woniupao and simpler. The prominent change of the pollen records is the increasing of the percentage of Pinus and Cocos since 6,000 years BP. It represents the immigration event of temperate forest into the boreal forest and linked to the weakening of the East Asian winter monsoon since the Middle Holocene. As the percentage of the Pinus and Cocos are relatively low in these two records, we want to compare them with other pollen records nearby to confirm that it is at least a regional event. We find that the extension of Pinus and Cocos is also recorded in other lake sediment from the middle to high latitude region of the Far East after 6,000 years BP. For example, in Sihailonganmar Lake, in Longgang volcanic field, Tianchi Lake, in Wudalianchi volcanic field, and Lake Protocol nearby the Beikar. Now we believe that the extension of the Pinus and Cocos is a regional event in Middle Holocene, and the content of them in pollen assemblages at this size are all likely to be inversely correlated with the strength of the East Asian winter monsoon. Until now, we can confirm that the contents of Pinus and Cocos could be used as a proxy of East Asian winter monsoon in northeast China. Then it is time to us to think about the cause of this shrinkage. Let's look at this figure. The red lines are the percentage of Pinus, the green lines are Cocos. The black line is the winter installation at the latitude of study area. The same tendency shows that the increasing winter installation could partly explain the warmer winter. The dark blue line is the sea surface temperature of the West Tropical Pacific Ocean. Its cooling will reduce the land-sea thermal contrast between Pacific and the Eurasian high in winter, which could also weaken the strength of the East Asian winter monsoon. However, these relative gradual changes could not totally explain the abrupt change of the East Asian winter monsoon in the Middle Holocene. So, other potential factors like tensile variability on Saturnia to Minerva timescales need to be considered. As the resolution of the record from Lake Noon is higher, this record is chosen to do the following mathematical analysis. this table presents the result of correlation between 11 major pollen taxa from Lake Noon and 2 time series of ENSO. High correlation coefficients imply significant relationships between percentage of pinus cocos and the frequencies of El Nino events. These results reveal a strong relationship between the East Asian winter monsoon and the ENSO events on Saturnia to Minilia time scales. Finally, we want to know why the strong linkage between El Nino events and East Asian winter monsoon only occurs at mid-Holocene. This figure is the result of violet analysis and bandpass filtering of the pinus cocos records from Lake Noon and the El Nino index from above. There is an obvious change of the amplitude of about 500 years cycles before and after 6,000 years BP. It has stronger variance after about 6,000 years BP. These about 500 years cycles originate from changes in solar activity. Opposite to the paleoclimate records, the amplitude of about 500 years cycles of solar activity diminishes after about 6,000 years BP. This indicates that the East Asian monsoon system is closely linked to the high latitude processes like global ice values in early Holocene, while the telecollections with tropic processes like El Nino becomes more significant during the middle to late Holocene, middle and late Holocene. So the climate transition in the middle Holocene is caused by the variation in solar activity and amplified by the ocean circulation or ENSO to influence the East Asian monsoon system and change the vegetation in Northeast China finally. In summary, the pollen records from Lake Woniupao and Lake Noon in Northeast China throughout the Holocene implies the shrinkage of the East Asian winter monsoon after about 6,000 years BP. The collections between the East Asian winter monsoon and El Nino events is obvious in Holocene. Solar activity may be the main driving force on of the ENSO and the East Asian winter monsoon on Saturnia to Millennia time scales since the middle Holocene. That's all. Thank you for your attention.
Thank you so much for your talk, and thank you for being our first speaker. That was fantastic. That's brilliant. I'll introduce our next speaker now, who is Vita Gomes from the Federal University of Para, and the title of the talk is What Pollen Can Tell Us About Amazonian Tree Species Distribution. So look forward to this. Thank you.
Good morning, good afternoon, and good evening. Hope you guys can hear me clearly. So thank you. Shortly before I start, I'd like to thank you, the organization, Keith, Yoshi Maizumi, Nicholas Strenberg, and Lini Mao. It's a big pleasure to be here today with you guys in the Palynology short talk. So, first, a bit of myself. I'm an environmental scientist interested in understanding how Amazonian tree species respond to global change. Currently, I'm a postdoc fellow at USDA Institute of Geosciences. I'm based in Brazil right now. I'm a computer science professor and a member of the Amazon Tree Species Diversity Network, ATDN. You may find some more information about myself and my social media and my website, www.victorhsholmes.com. So, I brought this title for you guys. What Pollen can tell us about Amazonian tree species distribution? Actually, it's not the title of my paper I presented to you, but I'd like to speak and tell you guys address some important points about Amazonia. So, first of all, Amazonia is big and old. The forest is the largest single block of tropical forest in the planet, and it has been shaped during millions of years, influenced by geological and climate process. So this is Amazonia. I think it's important to show the size of it. And maybe some of you know the Netherlands. This is the Netherlands compared to the Amazonia, the green line, the thin green line. The Netherlands is roughly the size of the Marshall Islands, the largest fluvial marine island in the world. Yeah, so Amazon is really big. Hope Hans Tarsteja is not here because I took this image from one of his presentations. So, Amazon also holds an incredible biodiversity. 1/60 of all known tree species in the planet occurs in Amazonia. The number is around 10,071 species of roughly 60,000 species. This is incredible biodiversity. For instance, in the Netherlands, we have mostly around 40 native tree species. So that's a huge amount. The tropics, right? I used the Netherlands because I used to work there. So global change has been impacting Amazonian rainforest. The big, old, and diverse forest experienced marked climate-driven change in climate conditions since the last glacial maximum. And the current human-induced change has impacted the forest, threatening its biodiversity. So this is really important for us. I like to start this global change and how global change impacts Amazonia. So we try to estimate how global change impacts Amazonia. We have been trying to estimate those impacts in the present and also project possible future impacts. But some people are in denial about climate change. You must be aware of it. So we try to look back into the past to show how climate has changed Amazonia along the time. And we think this is important. So we can project global change impacts into the future. Then we have this lovely paper produced by Frank Mayo and colleagues, Millennium Scale Dynamics of Southern Amazonian Rainforest. And basically, they show that very recently, geologically speaking, times, during the 3 past millennia, a significant change happened. This paper showed that during the Holocene, Amazonia expanded southward at the expense of Sahara savannas. They pointed that by analyzing late Quaternary pollen records from the southern margin of Amazonia. So we have these 2 lakes in the southern part. You can see these 2 yellow dots. They are Laguna Bella Vista and Laguna Chaplin. Those pollen records were extracted from sediments of those two lakes, marked by those two yellow circles over there. And Laguna Bella Vista and Laguna Chaplin showed a marked increase of pollen concentration. And low precipitation of Mauritian pollen characterized the most of the Holocene sequence. Those lakes are 100 kilometers away, farther from each other, and the pollen concentration of the Mauritian in both lakes increased during mid to late Holocene. So the evidence we have is that the concentration of pollen of Amazonian tree species increased during mid to late Holocene in those lakes, and since they are further from each other, 100 kilometers away, we expect that the forest actually expanded proportionally between those two lakes in the three past millennia. And this is attributed to Intertropical Convergence Zone, or ITCZ, the region where those two lakes are placed is influenced by a strong seasonal climate, produced by latitudinal shifts of the Intertropical Convergence Zone, which is overriding control over the geographical position of the southern limit of the Amazonian rainforest. As we can see, in the northern, we have the ICTZ acting during austral winter, and in the southern part, we have it acting during austral summer, bringing warm, moist Amazonian air masses responsible for the rainy season. So this forest expansion during the three last millennia is largely attributed to this latitudinal shift of Intertropical Convergence Zone. Since we have those evidence about the increase of pollen, and that is largely attributed to climate change. So we thought, why not modeling tree species distribution and figure out if the environmental suitability for those species increased during mid to late Holocene. So we produced this paper, was an early review since March in a Wesley's Journal of Biogeography, now was published in the July issue. And the authors, myself, I had the honor to work with Frank Mayo, William Gosling, two well-known paleoecologists, and they also know a lot about Amazonia. Ima Vieira and Rafael Salomão, also two experts in Amazonian tree species, and Hans Arceja, my supervisor, and of course one great ecologist that knows a lot about Amazonian and mostly tree species diversity and distribution. So our goal was to access the environmental suitability for rainforest tree species across Amazonia during mid to late Holocene, and then we tried to find if the environmental suitability for those species actually increased, showed by the pollen data from the lakes of the southern part and the lakes from whole Amazonia. The taxon, we studied three species of Mauritius and Urticaceae. Actually, most of the pollen is attributed to Mauritius, but we cannot reliably distinguish between Mauritius and Urticacean pollen. So we modeled both families. And the methods, we used species distribution models. So to estimate species environmental suitability, and use the relative abundance models based on inverse distance weights to estimate three species relative abundance. And the two-phase pollen of spectra from 46 previously published paleoecological sites. For us, it was really important to compare the species abundance against the pollen concentration, so we could test if pollen is a good proxy for species relative abundance. In other words, our question was, could pollen represent the rainforest that we see nowadays? First, some results, abundance versus pollen. This is a map showing relative abundance of Mauritia and urtication lumped together in Amazonia. You may see that in the southern part, we have this bluish pattern showing that the relative abundance of both species is high in the southern Amazonia. In other words, we have lots of trees of Mauritia and urticaceae in the southern part of Amazonia. The green circles are the relative abundance of the families on ATDN plots. We used roughly 2,000 plots of trees of the ATDN Amazonian tree species as a network. And in the yellow circles, you may find the concentration, the pollen concentration for the 46 paleoecological studies we researched. And what we found a significant and positive correlation between species abundance and the pollen concentration. So we may say that when the pollen concentration increased, abundance also increased. So pollen of those species is a good proxy for species relative abundance, which is good, because we in the future may look into the past concentration of the pollen of those species and maybe try to reconstruct species abundance in the past. Another interesting result, when we modeled Mauritian alone and urtication alone, we found that the correlation of Mauritia against the pollen of Mauritia and urtication lumped together showed a higher correlation than urtication. So we could imply that actually most of the pollen of those species may actually be representative of Mauritia. And Frank Mayo already had addressed that in his paper in 2000. In this image show us the relative abundance of Mauritia in the left and the relative abundance of urtication in the right. So you may see that Mauritia mostly drives the distribution pattern of those species in the southern border of Amazonia. So probably the pollen that we find in those two lakes is a representation of Mauritia's family. And then we modeled the environmental suitability between mid and late Holocene for the whole Amazonia, and we found increased environmental suitability for those two families in the southern part. We also found that the environmental suitability also increased in the northern part. But now this image is cropped. We cropped the environmental suitability map used in the Amazonian area. But if we didn't, you could see that actually environmental suitability for those species increased for the whole South America, and especially, of course, in the southern part, showing that actually some climate change occurred in this area, and then probably move in the distribution of those two families further. Another interesting pattern we found. In the left, we have the relative abundance of Mauritia and urticaceae, and in the right, we have the species richness. So they seems to match each other. Where species relative abundance is high in the southern part, we have this low species richness. So we may say that species are abundant where the species richness is low, because the higher the species richness, the higher the competition. It is in those species, they are early common species, they are expanding. So a few species are moving further with a lot of individuals. And I'll draw some conclusions here. First of all, increase the environmental suitability during mid and late Holocene. We have shown that mean environmental suitability for Mauritia and urticaceae tree species increases during mid and late Holocene throughout Amazonia. especially at the equatorial rainforest savanna boundaries towards the northern and the southern margin of Amazonia. Paleo-environmental interpretations strengthened by modeling results. So our modeling results strengthened paleo-environmental interpretations from early fossil pollen studies. That is, the long-term trend of rising precipitation through the middle-late Holocene increased the environmental suitability for Amazonian tree species in the Mauritia and Urticaceae family, thereby facilitating the range expansion at continental boundaries. Under a future warmer, drier Amazonia, the expansion will probably be reversed of the 21st century. Our results imply that under the future warmer, dry Amazonia, as predicted under most global circulation models, it's likely that the late Holocene range expansion of Mauritian Urticaceae and many other taxa will be reversed over the 21st century due to the increased moisture stress leading to large forest and diversity loss, especially in equatorial areas of Amazonia. So guys, those are the points I would like to share with you today. Really thank you for the opportunity and open to questions in the moment, at the appropriate moment. Thank you very much.
Thank you, that was fantastic. We have some questions and comments coming in, but I'll save those until the end.
Yeah.
So yeah. So I'll ask if Limi would be willing to introduce our final speaker now. Are you there, Limi?
And yeah, hi, I'm back again. So the last speaker, Dr. Yu Shaohua, she's from Guangzhou Marine Geological Survey in South China. And her study interests including marine palynology and coastal environmental change. Today, she's going to talk about the research linked to the project evolution of the Hainan data as response to the paleo-environment science in the later Pleistocene at the South China Sea's northwestern shelf. So let's look forward to her talk. Please, Dr. Yu Shaohua. Shaohua, I didn't see you. Something wrong?
Hello, everyone. Thank you,
Hi.
Professor Mao. Good
welcome.
morning and good evening, everyone. My name is Yu Shaohua. Should I share the screen first?
Yeah, please.
Okay. Where is it? Oh no. Sorry, please wait a minute. Okay. Is it done now? Can you see? Yeah, you can see.
Not yet.
Not yet.
So share your screen.
Yeah, I shared.
On the bottom of the window.
Where is it? Sorry.
Have you found the icon? Screen, share screen.
Yeah, I found.
Click it and then comes the window to choose. Yeah.
Is it right?
It's going out.
Okay, okay. Wow. So
now, yeah, no problem.
But where? Good morning and good evening, everyone. Today, my name is Yu Shaohua. I come from Guangzhou Marine Geological Survey, China Geological Survey. My topic of this presentation is pollen record in the northern western western continent shelf of the South China Sea in the past 82 Ka, Palynology environment changes in the last glacial period. How can Sorry, please. I need to wait a minute. Okay. As we well know, the Magellan Sea is collected the continent and the ocean, and the environment was strongly impacted by the interaction of land and sea, especially in the South China Sea, which collected the strongest land Eurasia and Pacific Ocean, and the South China Sea has accumulated amounts of terrestrial materials from the big rivers. During the cycles of glacier and in the glacial period, the continental shelf has exposed several times during the glacial period. As the sea level has dropped more than 100 meters. But what's the pioneer element of the exposed continental shelf was still not clear at present. Our study area was focused on the northwestern of South China Sea, the southwest of Hainan Island, China. The climate in this area was impacted by the Indian monsoon and the East monsoon together. The past pioneer records at here and the seismic data has indicated that this place has accumulated amounts of terrestrial materials, which has a great potential of reservoirs of oil and gas. Whereas the source of this heaven sediment is still obscure. Some researchers doubt that this sediment could solely from the Hainan Island, but the new seismic profiles also suggest that it originates from the drainage of the Red River. To solve this question, existing seismic data should be complemented with palynology evidence from cores. So our questions in this topic has three. The first is the source of the sediment in this area is current and unclear, and the mechanism responsible for the Highland Palyno River Delta, the formation of it is unknown. The element variation of the coastal area in this period is obscure. Pollen is a terrestrial material that faithfully records its continental heterology as well as local climate and vegetation composition. The marine pollen are mostly transported by river wind, ocean currents from the continent, so that we can find some trace from the marine pollen by finding out the terrestrial materials. Past marine pollen records are mostly focused on the northern eastern South China Sea and has demonstrated that the main transport way in this place was big rivers. But the study area still has not the long records of the marine pollen. Nearly a terrestrial core in the Hainan Island spans to 400,000 years ago. Okay, this is, and our core set is this ZBW is located in the northwest of South China Sea, Beibu Gulf, and the southwest of Hainan Island. Core depth is 105 meters, and the seismic data and dating has showed that a high-speed sedimentation has took place during 65 Ka to 6 Ka. The dating was composed by the AMs S14 and OSL. This is the samples for the dating. This is the sediment element has been indicated by the green size seismic data lithology, foraminifery, and data flagellants. The core features were relating coast marine features and river lava or shore fissures, which seems to reflect sea level changes during the glacial interglacial period. This dynamic sedimentary element gave rise to 7 distinct fissures. Okay, the photographers of the course had also showed the represented sedimentary units, and the glacial periods with more coarse sand. We can find that the fissure 3 and fissure 3 and fissure 7 there has a period of the coarse sand. Okay, 92 pollen taxa have been identified in the marine core samples, including 55 arbory pollen taxa, 14 herbers, and 23 fern taxa. Cornices was used to fashionate pollen zones based on a cluster analysis of the pollen assemblages, resulting in a coarse division into 5 distinct pollen zones, many traces of pineals and cyclobaropes. In the glacial period, cyclobaropes has increased, while in the interglacial period, pineals increased. Okay, we can find that there is 2 distinct different pollen zones in the whole core. In order to find out the source of pollen in the core ZBW, the modern analog pollen technique has been applied into identify the modern pollen assemblages, and with the results has found the most for this purpose, 3,244 modern pollen samples from the East Asia pollen database were used. Results have demonstrated that most terrestrial pollen in the ZBW core came from the Yungui and Tibetan plateaus, indicates that most of them were carried by the Red River into the Beibu Gulf, then scattered into the northwestern South China Sea, especially when the sea level dropped more than 100 meters during the glacial period. A large continent shelf was exposed. The Red River estuary extended to cover the core set nearly completely and form the highland Palynology River delta with a high sedimentation rate. Okay, just looks like this. The pollen concentration in this core correlates strongly with the sea level and variation and the distance from the pollen source. When the sea level falls to its minimum in mid-fall, the pollen assemblages changed significantly. The percentage of cyclobaropes increased to 33%, while that of pineals decreased to 64%. The contribution of lowland trees also decreased significantly, indicating dry and cool climates with strong erosion in the mid-fall. Strangely, other records from the northeastern of South China Sea has showed that more herbers in the glacial period, maybe because they have different pollen source and various climate-driving mechanism. Okay, we also use the PCA analysis. The results also presented cyclobaropes and pineals have the most positive and negative positions in the PC1 axis respectively. It indicates that PC1 naturally reflects the temperature and that MIS4 was significantly colder than MIS5 and MIS3. In general, an increase in pineals pollen levels in marine sediments also indicates that the climate is becoming warmer and wetter. As demonstrated by the records of the East and the South China Sea, various types of tropical and subtropical pollen taxa are located along the positive part of the PC2 axis, and just two taxa, Pinus and Cyclobalanopes, located in negative positions. Ecological characteristic of this taxa indicate that moisture is the main loading factor of PC2, implying Mis4 was driver, then Mis3 and Mis5 of the detected arboreal pollen taxa. Compared with other paleoclimate data, we could find that the early Mis3 was the warmest and wettest period during Mis4 to 2, and coincided with an increase in the intensity of the Asian method and northern solar insolation. Seismic data revealed a deposition process that occurred in the so-called Highland Pena River Delta between 65 and 56 Ka. Our results indicate that this coincided with a transition from a period of low sea levels to one of higher sea levels, and a transition from a cool and dry climate to one that was warmer and wetter. Delta formation began during the cool dry period when the rate of continental erosion was high. As the sea level rose and the climate became wetter and warmer, the rate of erosion was greatly reduced, ending the delta's rapid accumulation. Okay, these pictures are part of the representative pollen taxa in the ZBW core. Okay, let's get a conclusion of this topic. Firstly, a high resolution pollen record spanning the last 82 Ka for the northwestern continental shelf of the South China Sea. Second, analysis of the sedimentary element of the ZBW core revealed water-lating coastal marine and river rover between Mis4A, 5A, and Mis1. Third, pollen in the core originate mainly from the Tibetan Plateau and Yunnan province, which constitute the drainage basin of the Red River. Fourth, the Palynology record was dominated throughout by arboreal trees, mainly Pinus and Cyclobalanopes. Fifth, arboreal trees dominated between Mis5A and Mis1, including the glacial period, and the high contributions of Pinus and lowland trees indicate a warm, wet climate in Mis3. Six, the Highland Pena River Delta process was coincided with a transition period from cooler and drier climate to warmer and wetter climate, and lower sea levels to higher sea levels. Okay, thank you everyone. I'm ending my presentation. Let's drop.
Thank you for excellent talks.
Yeah,
please, Mishra.
Yeah, thank you. So we have about 20 minutes now to go through some of these questions that have come in. The first question is for Vitor. How did you refine fossil pollen data for Urticaceae, as some of them are not tree species but herbs?
I don't know if I got it. How did they make difference between tree species and herbs?
Yeah, so how do you tell, how did you refine fossil pollen data for Urticaceae, and some of them are not tree species but herbs?
No, we didn't. We were just guessing and trying to find some interesting correlations. And since we find significant correlations and also higher correlations. We suppose, and we make clear in the paper, that we expect that most of the species could be moraceous species, and of course tree species. I don't know, maybe if all the pollen could be a representation of the tree species, maybe the correlation would be even higher. But we expect that most of the pollen would be of tree species. Then we have this huge data set of tree species from ATDM, the Amazon Tree Diversity Tree Network. And then we compared and find some significant results and correlations, high correlations. So we didn't. We just look into the pollen diagrams, and then we extract the percentage of pollen of moraceae and urtication.
Thank you. I think that the next question is also for you, Vita, from Tia. In the maps, how confident are you about the interpolation in the areas with few plots, especially considering the overrepresentation of plots near rivers?
The confidence about the relative unit maps, I think.
Yeah, if you're here, Tia, if you want to elaborate.
Yeah. We've been using those maps since I don't know. Hans used those maps since I don't know, roughly 15 years by now, and we have been using those maps, relative unit maps, to estimate tree species distribution in Amazonia. And then we compared in 2018. We published a paper in a scientific report comparing relative abundance maps and environmental suitability maps. Actually looking for correlations, looking for how those maps match each other. Could those be a good representation of tree species distribution? So we trust in those maps, but I didn't get the question if I have confidence in the maps based on the overrepresentation of the plots, was it?
In the maps, how confident are you about the interpolation in the areas with few plots, especially considering the overrepresentation of plots near rivers?
Yeah, speaking about this particular case of moraceae investigation, those species are really good in the southern part of Amazonia. We are not just guessing. We know that for quite some time that those families are abundant in the southern part of Amazonia. And then Frank Mayo had this data showing that moraceous species increased, pollen concentration of moraceae increased in the past in the same region. So when we see a lot of plots in the southern part, actually it's a lot of plots that are showing the overrepresentation of moraceae. In other words, there is quite a individuals of moraceae in the area. So I don't know if I'm getting the question right, but we are confident in our maps. We have been using those maps and this kind of interpolation for quite some time now. I don't know if I answered it.
Thank you. Yeah, I think that's great.
If not, I can answer it. I can be more clear. I don't know.
Yeah, I think very many people were interested in your talk. There's another question for you. Some genera, such as Celtis and Tremor, are included in Moraceae. They are both tree species. What do you think about the future updates for these issues?
What I think about the future of the distribution of those taxa? Yeah, this is most of the data from I'm reading I'm reading the chat. The chat. The question was what I think about the future of the taxa.
No, let me clarify. It's about comments, not the question, because we know some genera such as Celtis and Tremor are not included in Moraceae family according to APG3. So they are both tree species. So if you include this data in your model, I think the results will be interesting.
Just to clarify, what are the other class, the other genuses? You mean the other genus?
No, two genus, Celtis and Tremor. Because it's very rich pollen from pollen diagram I saw from Amazon area. So please be careful about this two genus.
Yeah.
It's not about question, just comments.
Okay, yeah. Right now we are investigating, we are including other taxa in our analysis. Now we model the whole Amazon area and we look only to Moraceae identification, but we are starting making questions regarding the whole Amazonian tree species pollen available. So probably we will expand in the future. That is the goal of my postdoc research. We are trying to investigate the past and now looking to the other taxa. What else could we find?
Okay, thank you.
Thank you. We'll give you a break for a while, Rita. We'll
okay.
go to
Sorry, now I see. Celtis and Trema. Sorry, really
so,
sorry. I was not understanding.
Can we both go back to the first question for the first speaker?
Yeah.
Chris Liu asked Dr. Wu Jing one question. So Wu Jing, are you there?
Yeah, I'm here.
Yeah, have you seen the question in the chat?
Yeah, I have seen that.
So please explain that.
Yeah, explain that. I first think that I think for the lake sediment, they have regional source, but not local source normally, right? So we couldn't only use the pollen to discuss the local vegetation. Especially, I show the size of the lakes. And I think Lake Palynology is medium lake. That means that perhaps the source of the pollen is about at least more than 10 kilometers longer. And she suggested that we should use some other evidence like stomata and valves. And valves, I can't decide that because for both of these lakes, they don't have valves. And the stomata, they will have some problems like Lake Room. We can find the stomata in the sediment, but for Palynology, it's too bigger to find stomata in lake sediment because it's quite far away from the bank of the lake, because the stomata always deposit with the leaves or the things, something like that. It not really transport like pollen. And we did some works on stomach before, but it's public in Chinese, so we can have a look at it. Notice the time scales from the last glacier to the early Holocene. And sorry for that, this is Chinese, it means Laris, Sabina, and Pisia. So it means that in the early Holocene, in this region, we can't find the stomata of the pinus. And if we we also did the plant investigation in this area today. We could find the pinus partly distribute in this area, but quite few. So it means that I think this means nowadays we have more pioneers in this area. Okay, is that I really answer the question?
So Larynx pollen, we always found a very low representation. So as you found the stomata data, it's very good. But how about the pollen? So it's difficult to balance
It's
there.
quite low. Sorry, it's quite low, especially with the high presentation taxa like Betula and Artemisia and Demerense, something like this, and it will be quite low. And even we try to find counter more grants, but no help for this. Sorry.
Thank you. Very good job. So Nichira, we go to another question for Vita. I saw a question from Dr. Iman Fang. She asked about how do you calculate the species richness, and how do you think the species richness linked to the pollen abundance? So Vita, can you explain that?
Yeah. We calculate species richness based on environmental suitability maps. We stacked those maps, so where species are predicted to occur. So we sum the number of species that occurs in each of the cells of the map. We used this approach before, and then we use this approach now to calculate the species richness in the past and currently for Amazonia. So we stack. We take one species distribution model map for one species, and then we put on top of the other one, and then we calculate all the number of species predicted to occur for each one of the grid cells of the map. And how do you think the species richness will link it to pollen abundance? Yeah, well, actually we tested that, and we found no specific correlation or significant correlation. The paperwork starts to become big, and then this is a different question, but I tested, and we found no specific correlation between species richness and pollen abundance. In other words, we tried to find some correlation between richness and abundance in the past. What we do know is that the species richness tends to be higher, where species are less abundant. So we could expect to find some negative correlation, but for this specific taxa, we didn't find any significant correlation.
So Iman Fong are happy with the answer?
Thank you, Victor. I'm Iman. And the first question for my perspective, I just wanted to ask which index if you used in calculating the species richness, like Shannon index, Simpson index?
Okay, no. This was a different approach. What we did, we have this environmental suitability map. So we predict where species have higher probability of occur. So we stack the species distribution models, one on top of another, and we calculate how many species are predicted to occur in each one of the grid cells of the map.
Mm-hmm.
So we calculated the species richness based on species distribution.
Ah, I see. Thanks. Thanks. Good study.
So move to next question from Dr. Deke Xu. He asked, during the late Holocene, human activity may also have a great impact on pollen abundance. Can you give us more information about that?
During the late Holocene, you mean the last decades or centuries? I think, well, That's not my specialty, of course, but since I'm concerned about how global change affects species in Amazonia, what we can say when you have a land change, land use change in Amazonia, so we expect that pollen could also be impacted. Of course, the pollen data we used, they were extracted from ancient lakes. So if those lakes are impacted, we could expect that those information is lost. Basically, the pollen in Amazonia is carried by by water. So the rain washes the pollen, and then the pollen is deposited in the sediments of the lake. So based on this orange of the pollen data we are using, we expect that we have not high impact. But of course, if land use change, and we have a lot of huge impacts running in Amazonia nowadays, mostly driven by logging and the farms. So maybe we could lost those information, lost those information.
So Dr. Xu, are you happy with the answer?
How do you separate the human effects? There is another one. How do you separate the human effects from natural process? Again, what we did was very basic. We look to the pollen diagrams of several studies. We took information from 4 or 5 pollen diagrams, and then we looked to the surface pollen concentration, and then we extract those information. So we did not run any analysis, specific analysis for human impact or natural process in our studies. In fact, we just looked to current pollen because of this. Since we were not prepared yet to look past to pollen information in the past, because of this, we had to separate human impact, natural process, especially for the Holocene. We had fire impact in the past. So we choose just to look for present pollen and not past pollen. And then we compare the present pollen with species relative abundance we know in the nowadays.
Thank you. Because of limited time, so we have to move to the last speaker's questions. Yeah, the first question to, yeah, thank you. So the first question to Yu. Did you differentiate the dinoflagellate types in autotrophic and heterotrophic? The latter has a strong relationship with genus input. So can you see the question in the chat?
Yes.
Yeah.
Yeah, I'm here. I didn't differentiate the dinoflagellate types in ultratrophic and heterotrophic because I'm not a specialist in the dinoflagellate. We only count in the pollen slides in the macro, use the macroscope. And I think the dinoflagellate in the coastal area has a strong relationship with the heterogeneous input. I agree with this point. Okay.
So next question.
Next, following up, next question.
Yeah.
Okay, you want. I think it's according with the Asia Mason, because the terrorist input was controlled by the Asia Masons. So this could have been due to the increasing strength of the Asian submarine during the early part of mystery, and it could we can conclude that the early mystery was warmer and wetter during this period. Okay, the last one, you mentioned the pollen.
Let's comment. I think you can skip that. That's about the pollen source area. You mentioned that's very far from Yunnan and the Tibetan Plateau. But how about local or regional pollen signal contribution from west coast areas from Vietnam?
Local.
Local or regional, because Tibetan is very far. Yeah.
The present contribution, I think, is we need to compare with the surface samples. It mainly from the big rivers at this place, I think, because our core is during during the next glacial period, especially during the Miss 4 to 2. We compared with the main pollen assemblages and with the Asia database, surface pollen database. So we found the most similar pollen assemblages are from the Yunnan and the Tibet plateaus. You can see the picture of this. Should I share the screen right here?
I think that's fine. So the last point is about in your data set, mangrove pollen are missing, but in the coast area, I think from west coast of Vietnam and Hainan Island, also a lot of mangroves. So there's very few mangrove pollen there you found. So how do you explain that?
Yeah, we haven't found much mangrove pollen in this core. I'm not sure what's the problem, because maybe it's a problem from the pollen extraction, or maybe because the environment is not suitable for the existing of the mangrove type, because the mangrove only live in the coast area, and the sediment in its core is most of them from in the glacial period. So
okay,
my explanation.
Thank you.
Thank you.
Thanks so much for taking the time.
Let's go back to additional question for Dr. Wu Jin. That's also from Fang. So you mentioned the 500 years cycling related to the solar activity. Then she would like to know, is it more contributed to winter isolation or summer isolation?
Yeah, I should say the insolation is on the orbital orbital scale. It's quite different from the solar activity. Solar activity is normally like we familiar with like 11 years or something like this, and it had longer cycle like 500 years. So it won't really have some influence on the insolation. Yeah. So, but I think maybe if the question is about the influence of the about 500 years cycles on the summer monsoon or winter monsoon, then it becomes that it will influence both of them. Okay. Did I answer the question?
Thank you. So go back to Dr. Victor. Someone asked you, is it possible to share your slides, share your presentation?
Yeah, just let me know how to do that. Where do you guys prefer?
You can put it on chat. Also
Okay.
Document, support
Okay, I
document
see here.
to
Yeah.
share.
Yeah,
Okay,
there
back
is
to
a file
Nitara.
written. I'll do that.
And additionally, if any of the speakers are interested, we do have the capacity to host maybe like a PDF PowerPoint presentation on our website if we want to consolidate these for all of the speakers. But that's totally optional. We can discuss that individually with the speakers in the future.
Let me get this straight. So we wait and then we make available in the website, so?
Yes,
Yeah,
please. That would be
that works.
fantastic.
Okay, then I'll wait. Wait, then I can share with you. Don't share it now, right? Because of the limit.
Yeah,
Okay,
and
that's
once
fine.
we close the chat, we will lose the download link. And so it will just not make you have to send it twice. So if you want to email it to us, Victor, that would be great. And we'll get it onto the website for future sharing. And if either of our other speakers would like to do the same, if you could send a PDF version, that will be easier for us to share.
Okay.
Okay, so thanks everyone. I think maybe we should wrap up there. But I just want to say a huge thank you to our three speakers. That was absolutely fantastic. And I'm sure many of us are feeling very inspired now. And it was the lift we needed right now. So thank you so, so much. It was really great. And thank you to everyone who's watched and who's asked questions. And we hope you'll be able to join us again in about a month's time to hear about human impacts in palynology. So thank you and goodbye, everyone.
Thank you. Goodbye.
Goodbye.
Thank you. Bye.
Thanks.